Hello dear students, welcome to Functional Studies 101. So this is a continuation of the series on differential calculus. Today we are going to be looking at the product rule. Last time we saw how to differentiate the tangent function, tangent of x from first principle. So today we'll continue with the product rule. And also, if you are new to this channel, kindly hit the subscribe button and don't forget to turn on the notification bell so that whenever new uploads are made available, you receive an instant notification from YouTube. And also, to get to me, you can send me a text message using the number on the screen and I'll reply to you on WhatsApp. I am Temgun48 presenting this script. So without wasting much of your time, let's get started. So as we know, we are looking at the product rule. So the product rule when is used when you are differentiating the product of two functions, okay? And these two functions must depend on the same variable. Point to note. So if u and v are functions of x, okay, let u and v be functions of x. Now if you have a certain function y which is the product of u and v, which are functions of x, when we say they are functions of x, it means that what the independent variable in each of these functions is x. So the functions depend on x, that's the inputs. So in other words, rather than using this statement, you can write it as u of x, u bracket x times v bracket x is the same thing, but this is more simplified if you just define this. Now the product rule says if y is a product of these two functions u and v, which are functions of x, then the derivative of y with respect to the same variable x, that's why we write y prime. Whenever you see a prime written on a variable, it means it is the differential coefficient of that variable with respect to x. Yes. So rather than writing dy on the x, it takes up a lot of space. So it is accepted anywhere you go around the world. So it is customary to write dy by dx by what? Y prime. So it's customary to write any variable that is differentiated with respect to x as that variable prime. So in this case, dy by dx is y prime. So that will be equals to, the product rule says we take a first function, keep it without touching it, as you can see u, and we differentiate the first function. Remember, we are differentiating with respect to the independent variable, which is x. So since we are differentiating v with respect to x, that will be dv on dx. According to the universal principle, it is customary to write it as v prime, okay, plus, now we'll keep y, the second function, which is v, unchanged, and now we'll differentiate the first. So you are seeing it now. So we'll keep v and differentiate u with respect to x. Take it again. To differentiate the product of two functions, you keep the first part untouched and differentiate the second function v, okay, plus you now keep the second function untouched and differentiate the first. Now from there, let's look at an example to see how this is applied. So we have to differentiate with respect to x the following function: y equals to x squared plus bracket x squared plus 1. That's x squared time. Whenever you see these brackets like this, okay, it means multiplication. So that this term x squared is multiplying all of this. That's the meaning, okay? So now to do it by product rule, we'll call the first function u and the second function v. So you see that y is a product of two functions, this polynomial x squared and this other polynomial x squared plus 1. Okay, so one part of the product will be u and one part will be v. Another student might let u to be equals to x squared plus 1 and v to be equals to x squared. The order does not matter because multiplication is commutative. So don't cram the formula, just understand the principle. Let u be one part of the product and the other part will automatically be v. Okay, so now according to the product rule, we have to look for what? Once you have let u and v, you have to differentiate them with respect to x. So when you differentiate u with respect to x, that's u prime will be equals to what? Use the power rule of differentiation now. So differentiate this and copy the power. This is just a review. I copy the power, then I reduce the power by 1. Copy it in front of the function like this. Okay, multiply by x. Then now to differentiate v with respect to x, same thing here. When you differentiate x squared, you have 2x now, and when you differentiate this one is a constant. Following the other videos that I produced, the first series or the first part, all these things were well explained there. So if you don't understand, you can go back and watch it. Okay, the links will be made available in the description. So when you differentiate any constant, the result is 0, no matter how large the number is. Whether it's a fraction, so long as it's a constant, the derivative is 0. So all we need to do now is to apply the formula, this formula. So the formula says y prime is equals to u v prime plus uv vu prime. So you keep the first function unchanged, differentiate the second, then keep the second function unchanged, you differentiate the first. So it's easy to keep it like that. So you don't need to cram the formula, just keep that statement in your head and you are good to go. So all you need to do now is just to substitute. What is my u? U is x squared and v prime is 2x. So I have x squared times 2x plus v is what? X squared plus 1 multiplied by what? U prime. U prime is 2x. This is it. All we now do is to simplify this. You can use any. Somebody might factor out 2x, which is a smart move, and another person might decide to do what? Expand directly. When you expand directly, you have 2x cubed plus this time this is what? 2x cubed, then this time this is 2x. So this is the final answer. Okay, so if you see here 2x cubed and 2x cubed, they are like terms, so we just add their coefficient and maintain the variable, right? So that will be 4x cubed. 4x cubed, sorry, it's not 3, I'll correct that, that's 4 plus 2x. Finally, that's the example 1. So example number 2, I just want to give you other examples so that you better understand. Example number 2, we have to differentiate with respect to x. The new function now is y equals to x sine of x. Same thing, we'll let u to be one part of the function x and v. It doesn't matter if you take sine x to be your u and this, just choose any one of your choice. So long as it's a product of two functions, you can apply the product rule to differentiate. Okay, so all we need to do now is to do what? Look for u prime and v prime. Once you have let u and v, you have identified your u and v. Where you differentiate u with respect to x here, you have 1 now. Yes, because I told you once you are differentiating a constant times x, okay, and you are differentiating with respect to x, automatically the answer will be the coefficient of that x. When the power of x is 1, okay, that's x to the first power. Then now when you differentiate v is sine x. When you differentiate v with respect to x, you have cosine of x. Finally, we just have to recall the formula. Y prime is equals to what? Keep the first function unchanged, differentiate the second, plus keep the second function unchanged, differentiate the first. Okay, so you now have to just substitute in the formula. U is what? X, and v prime is cos x. Then now my v is sine x, the u prime is 1, so 1 times sine x is just sine x. So this is the final answer. So we'll look at the last example for you to just understand, and then I'll leave you guys with an assignment that you do and submit on WhatsApp using the number I give you on the screen. So we are going to let u to be the first part of the function and v to be the other part. This is a product of what? S squared times square root of 1 plus s squared. So my u is x squared and my v is square root of 1 plus x squared. From there now, we just have to look for u prime and v prime. Okay, u prime, where you differentiate u with respect to x here is just 2x, and where you differentiate this one, I'll leave it to you to do. Okay, this part, differentiate v with respect to x. In the last video we saw the chain rule. Okay, we also saw the chain rule now. Yes, so you use the chain rule and differentiate this, knowing that this can be written as 1 plus x squared raised to the power of 2, 1 over 2. Okay, from there now you apply the power rule. According to the chain rule, you apply the power rule, right, normally, and then multiply by the derivative of the function that is inside. But I want you to note that when you have a function, let's say y equals to square root of f of x, to differentiate that function, the answer will just be f prime of x. That's you differentiate whatever you find inside the radical. Okay, that's it. So when you differentiate, you have 2x divided by 2 times their product. This is a shortcut that you need to know, so that when you see any radical and you're differentiating, you just quote the result without doing substitution and thinking too much and simplifying a lot. So the answer is just the derivative of what you find inside here, which is 2x, divided by 2 times the function that you are differentiating. My function is 1 plus s squared, so I have 2 times that function. Now the 2's can go, you are left with x divided by square root of 1 plus x squared, and you are done. All we need to do now is just to apply the formula. Keep the first function unchanged, differentiate the second, and keep the second function unchanged, differentiate the first. That's the product rule. So we just have to substitute. My u is x squared, v prime is all of this. So this dot means multiplication, so you just substitute, plus 2x, that is my v. Okay, v multiplied by a derivative u prime is 2x. So you can write it, it's better to write it this way in front so that you will not like you come and write it behind. Multiplication is commutative, and this is a better way of presenting it. So I'll leave you guys with this assignment. You have to differentiate these functions with respect to x using the product rule. So the first one is y equals to s squared times square root of 1 plus sine x. You use the product rule to differentiate. Then b, y is equals to 1 plus s squared, all that squared, times 1 minus x squared. So the c part is y equals to 2x divided by tangent of x. Don't be afraid of the problem, okay? And y is equals to what? The last one, sine of x over cos of x, which is just tangent of x. But I want you to use the product rule and show me that it is tangent. The answer will be secant square, because when you differentiate tangent is secant square now. So use the product rule as I say to show that the answer is actually tangent of x. I mean secant square, sorry. So now I've given you a hint so that you will not be lost. Use the fact that a over b is the same thing as a times b to the minus 1. So if it's a certain n here, it will also be minus n. Okay, so this is the end of the presentation. I would like to thank you for your kind attention, and please don't forget to subscribe, share the video to all your friends so that they can also benefit. Bye bye. See you in the next tutorial.